All right, so now we can introduce another terminology, and that term is the word hue. All right, so what is hue? Hue is the color's identity, or what color is it? So when you change the hue of something, you are changing that color to something else. So we've been using the hue and saturation adjustment layer in couple tutorials, and every time I asked you to change the hue, we got the color to be a different color because we're changing the color using the hue value. Now, how is hue defined? Hue is defined using something called the color wheel, and it's defined in degrees as we rotate at the color wheel. So at the top of the color wheel we have red, and that red is set to 0 degrees, and we rotate clockwise to get other colors. All right, so if you go online and Google RGB color wheel, you're going to find the same image that I'm going to show you now, or images very similar to it. So again, if you go online and search for RGB color wheel, you're going to get an image very similar to what I have here. So I'm going to close this one, and I'm going to go and look at this one. Sorry. So that's the RGB color wheel. All right. Now, let's discuss a few things about the color wheel. So again, it's a circle. We have degrees, and we start at the top with red. So notice that's 0 degrees. Do you know how many degrees altogether we have in a circle? We have 360 degrees. So if you go 0, we are increasing, increasing, increasing. We hit 180 halfway through. We keep increasing, increasing, increasing until we go back to 360 or 0 again for red. So if we start changing the 0 degrees or the hue, we're going to start switching colors. So at 60 degrees we get yellow, and then at 120 we get green, and then 180 cyan, 240 is blue, and 300 is magenta. Let's see if these specific colors and their location in the color wheel make sense. So I'll tell you two rules. All right, rule number 1, between every RGB color and the next one, what comes in between is the result of adding them. So halfway between red and green, what you get is the result of what you get if you add red and green. So if I add red and green, the result will be yellow. So that's why yellow is located halfway in between. What about green and blue? Halfway between green and blue is cyan. That's, again, if you remember, we talked about adding colors, and that's what happened when you add red, green, and blue, you get cyan. What about blue and red? You get magenta. So the reason why magenta is halfway between red and blue is because that's the color that you get when you add the two of them in the middle. All right, so that's one spatial relationship that is important to know. Another spatial relationship that is important to know are opposites. So here is red. Here's exactly the opposite of red is cyan. Here's green. Here's exactly the opposite is magenta. Here's blue. Here's exactly the opposite of yellow. Now, if you look at the RGB numbers, you're going to see that they are confirming what we've learned earlier. For adding, for example, adding red and green, it will give you 255, 255, and 0. That's correct. And if you reverse these numbers, you're going to get to blue, 0, 0, 255. And again, if you look at the numbers and how, if you reverse them or add two to each other, you're going to get the same exact results we wrote earlier when we were looking at adding RGB values and subtracting RGB values. All right. Now, one comment I want to mention is that the edge of the color wheel is where you have 100% saturation. That's why we're putting 255, 0, and 0. So assume always when you write the numbers at the edge that they are the maximum 255 and 0 numbers in these 6 particular famous values. Now, do I need to memorize the location and the numbers of the colors in the color wheel? I would highly suggest you do that. I think it will make everything fall in place a lot easier and faster in Photoshop if you are able in your memory to sketch quickly the color wheel. If I get you a piece of paper and say, can you sketch the color wheel, and you can draw a circle and plot on that circle where the 6 colors are, the 6 famous colors, and what hue value is used for each one of them, and what the RGB value used for them at 100% saturation, that will make you move in color correction way faster and will take a lot of the confusion out. All right. What we discussed earlier is why the logic behind these colors, why yellow is halfway between red and green, because that's what you get when you add them, why red is opposite to cyan. So that's the logic behind it, but that does not negate the need to memorize it. So when it comes to color correction, masking, all of that, it's important to memorize these values. So if I go back to my notes here, I wrote what is hue, and I said it's defined in degrees, starting at the top with red and rotating clockwise, and then all the colors on the edge are 100% saturation. So if you search RGB color wheel, you're going to get to that, but I'm going to type the word H for hue, and I'm just going to start typing few numbers. If we start at 0, what is that? And if you answer red, that's correct. And if we go to the next value is 60. What is 60? The correct answer is yellow. And then we go to the next value, 120. 120 is green. Notice how many degrees are we jumping forward each time? We're jumping forward 60 degrees. So we started at 0, we went to 60, and then we went to 120. So can you guess what's the next degree we should go to? 180, because we're adding 60 to 120. And what color is that? That's cyan. And if we continue, we're going to go to 240. What color is that? That's blue. All right. And then we go to the last one of these 6 colors, and that's at 300 degrees, and that's magenta. So you need to be able to do exactly what I did now. You need to be able to write all the 6 colors and their values and RGB numbers from memory, because that will help you understand the hue value. All right. All right, so I wanted to add one more term to what we're looking at, which is brightness. And brightness is how close a color is to black or white. All right. So it's defined in percentage from 0% to 100%. And the higher the RGB values are, the higher the brightness. So let's discuss this for a moment here. I'm going to go back to Photoshop, and I'm going to go to the color picker. So I double clicked here to open the color picker. And then once I have the color picker, now we understand RGB values. We understand also saturation. We also understand hue. Now we understand what hue values mean. But let's talk about this one, brightness. I'm going to drop brightness to 0%. All right. So this B is not blue. This B is brightness. This is blue. This is hue, saturation, brightness, RGB. If I drop brightness to 0, notice what I got. I got 0 red, 0 green, 0 blue. I got basically black. If I increase the brightness to 100%, I'm going to get 255, 255, 255. That's a white, basically, in that case. Now, as you increase or decrease the RGB values, brightness will be impacted. There's a couple things we need to mention here, that also saturation will impact that a little bit. So the reason why I see white at this point is because saturation is set to 0. But if I increase saturation to 100%, then that will result, because the hue value I have here is 0, which is red. So again, remember 0 degrees is red. So if I want 100% bright and 100% saturated red, that will give me 255, 0, and 0. Now, if I go, for example, to the brightness and put the brightness at 50%, notice what happened. I got 128. So the number of red went down, because I cannot go lower than that for green and blue. So in general, if I go here and increase this one, for example, to 155, that will increase the brightness. If I go and increase this one to 200, that will also increase the brightness. So as I increase RGB values, you're going to get higher brightness. And again, the easiest way to understand that is if you drop the saturation down to 0, now you are working in grayscale tones, because saturation 0 equals grayscale tones. And you can try to put 0, that will give you black. You can try to put 50%, that will give you the mid-tone gray, 128, 128. And of course, if you go to 100%, we're going to go to white. Okay. Now, how fast would all this make sense? The answer is really simple. The more you practice, the more you're going to start to see the connection between these numbers. The more you're going to see what happens when you change red, green, or blue versus hue, saturation, and brightness, and how changing one will impact the other values. It's not going to happen on its own. It's a matter of practice until you start connecting the dots and for things to make sense. But it's extremely important that you understand these 6 values and you understand how they relate to each other and how when you change one, it could impact some of the other values. If I go back to my document here, we talked about brightness. We said how close the color is to black and white. It's defined in percentage from 0 to 100%. And in general, the higher the RGB values, the higher the brightness value you will get. Okay, now I wrote here RGB versus HSB. I want you to know that the color mode is RGB. All right, so if you go to the channels palette, you're going to see a channel called red, green, and blue. You are not going to see a channel called hue, saturation, and brightness. So hue and saturation and brightness is another way to organize the same information exactly of RGB, but just in a different method, in a different way. Think about it as a coin, and you're looking at the other side of the coin. It's the same coin. You're just looking at the info from the RGB side, or looking at it from hue, saturation, and brightness. Sometimes making changes using RGB numbers will be easier. Sometimes making changes using hue, saturation, and brightness will be easier. It depends on what kind of change you're trying to do, but you need to understand the 6 numbers, and you need to know the range and what they mean. And you also need to know that the color mode is actually RGB.